All right, let's jump right into it. If you're looking to cut through the noise and understand exactly what's happening at the absolute bleeding edge of artificial intelligence, you're in the perfect place. Today, we've got a really fantastic explainer for you. We're taking a deep dive into OpenAI's major April 21st, 2026 release of ChatGPT Images 2.0. And look, this isn't just some minor tweak to their filters, we're talking about a fundamental architectural shift in how these models actually generate visuals. So get ready because we're going to break down exactly how this works, why it matters to your daily workflows, and what it really means for the future of AI-generated content. So think about this for a second. What actually happens when an AI image generator searches the web before it draws? It's a pretty fascinating concept, right? Look, we've all experienced the frustration of AI hallucinations. You ask for an image of a very specific, recent event, or maybe a complex technical diagram, and the model confidently spits out something that, well, it looks beautiful, but it's entirely factually wrong. It's that classic problem of an AI relying entirely on its static training data. But what if the model could just hit pause, do a little bit of research, and actually figure out the facts before it even picks up its digital paintbrush? Well, that is the exact problem-solution framework OpenAI is introducing here.
Okay, let's dive into this. Here's our roadmap for the explainer. We're going to cover the ChatGPT Images 2.0 upgrade, unpack how web-enabled thinking works, look at consistency across 8 frames, the new multilingual text and resolution bumps, the developer API and migration, and finally, the industry impact.
Starting right off with Part 1, the ChatGPT Images 2.0 upgrade.
Now, seeing the evolution of OpenAI's priorities over just a few short months is honestly brilliant. If you look back at December 16th, 2025, when they dropped GPT Image 1.5, the major selling point was raw speed, specifically up to 4 times faster edits than the generation before it. It was really all about making the tools snappy. But fast forward to April 21st, 2026, with GPT Image 2, and the focus has completely pivoted. The engine powering this entire new experience is no longer just about raw generation speed, it's heavily focused on web-grounded coherence and reasoning. The model is essentially trading a tiny bit of that immediate, raw output speed for some seriously complex structured planning.
Which brings us to Part 2, Web-Enabled Thinking Explained.
Let's unpack this new pipeline because it's super interesting. In the old days, you'd give step 1, the user prompt, and the model would essentially just jump straight to step 4, pixel generation. It was an immediate reaction based purely on its training weights. But that process in the middle, it has completely changed. Step 2 is now web retrieval and fact-finding, and step 3 is building a structured internal plan. Honestly, think of this new thinking step kind of like a human artist who just got a commission. They don't just immediately start throwing paint on a canvas, right? They go to the library, they do some research, they look up reference photos, they sketch a structural outline. And only after that grounding pass do they actually start rendering the final piece. That is exactly what GPT Image 2 is now doing algorithmically.
And this grounding pass, it solves some absolutely major developer headaches. For example, if you're generating infographics, factual accuracy is totally non-negotiable. If you're building multi-panel assets, you absolutely need spatial reasoning that holds up across the board. And crucially, if you're prompting about recently occurred real-world events, things that just aren't in the model's core training data, this web retrieval step is an absolute game changer. But we do have to note that this introduces a brand new dependency. The quality of your image is now inherently tied to the quality of that web retrieval. If the search service is bad info, well, your image is going to reflect that. So it's a remarkably powerful tool, but it definitely adds a new variable to your production pipeline.
All right, moving on to Part 3, consistency across 8 frames. 8. That is the magic number here. The model can now generate up to 8 images from a single prompt. And the kicker is, they all share visual consistency. Let me speak directly to the developers and designers tuning in right now, because this is going to completely change your day-to-day. Previously, trying to get a character to look exactly the same across different scenes required some incredibly tedious prompt engineering, a bunch of iterative in-painting, and honestly just a whole lot of luck. Now, this batch approach shifts all that heavy lifting straight to the model layer. This unlocks massive production efficiency for things like storyboarding sequential scenes without your main character just randomly changing hair color halfway through. It also allows for generating a UX mockup series where you get your light mode, dark mode, mobile, and desktop variants all in one single pass. And it means producing social asset packs where your brand consistency is just maintained across 8 different dimensions seamlessly. It's huge. Let's look at Part 4, multilingual text and resolution.
So, rendering legible text has historically been a persistent, frankly glaring failure mode for diffusion models. Characters blend together, words are misspelled, and non-Latin scripts often just degrade into these weird approximate glyphs. But OpenAI is specifically calling out some major upgrades here. Their documented improvements highlight highly legible South Asian scripts, Japanese manga-style panels that are actually correctly utilizing complex kanji, and multi-language editorial posters. And what's really vital to take away from this is that these aren't just trivial test cases with large, blocky English letters. No, these are meaningful, complex demonstrations of localized, text-heavy outputs.
And to pair with all that better text, the maximum output resolution now hits 2K. Combined with a wider set of aspect ratio options, this just provides a massive amount of headroom. For the vast majority of web and social media use cases, 2K is exactly what you need to go straight from your prompt right to publication without ever needing to run the image through a secondary upscaler.
Now for the technical side, in Part 5, Developer API and Migration.
So the crucial point here is really how rate limits scale for teams that are migrating their production workloads over to GPT Image 2. If you're a Tier 1 user, you're capped at 100,000 tokens per minute and 5 images per minute. But as you scale up to Tier 3, you're looking at 50 images per minute. And for enterprise teams up at Tier 5, you have a massive capacity of 8 million tokens and 250 images per minute. This really shows that OpenAI is actively ready to support heavy, automated, multi-image pipelines at a true enterprise scale. To actually make that move, here's your quick migration checklist. The pipeline structure is actually consistent with 1.5, which is great news. You'll just need to update your API parameter to GPT Image-2. But you definitely need to pay attention to these next 3 points. First, verify your throughput and latency differences, because that new thinking step might take a fraction longer than raw generation. Second, you need to audit your billing, because this reasoning pass might shift exactly how your tokens are consumed and accounted for. And finally, double-check that content policy, particularly around stylistic imitation, just because this new model is way more capable at mimicking very specific styles. Finally, let's zoom out for Part 6, the industry impact. Because look, none of this happens in a vacuum. Industry reporting, including some really great insights from Fortune, places this release in direct competitive pressure with Google's recent image efforts. Specifically, Google's Nano Banana releases and their subsequent user growth really helped spark a company-wide push at OpenAI to accelerate the deployment of ChatGPT Images 2.0. We are literally watching an arms race to build the most robust, all-in-one creative toolchain for designers and developers.
But of course, no matter how advanced the technology gets, human nature just remains undefeated. Despite OpenAI building a state-of-the-art AI with web-grounded reasoning, 2K resolution, and multi-frame coherence, users immediately leveraged its incredible stylistic range to emulate crude MS Paint-style doodles. Gizmodo documented this absolutely hilarious viral trend spreading across Threads and X, driven by users like @WithGrandRush and @ArrakisAI. Honestly, it's just a funny reminder that sometimes the ultimate display of a model's sophisticated control is its ability to perfectly mimic something remarkably unsophisticated.
And that brings us to our final thought for today. As AI models increasingly rely on the web to, quote-unquote, think before they draw, how will retrieval quality define the future of automated art? We are truly entering an era where the boundary between an image generator and a search engine is blurring. The capabilities of GPT Image 2 are undeniably powerful, but they kind of leave us with this double-edged sword. When your art relies on the internet's facts, who ensures the internet is actually telling the truth? It's something every focused learner, developer, and creator needs to keep their eye on. Thank you so much for joining me for this explainer. Keep exploring, and I'll catch you in the next one.